Guys, close the laptop.
I'm dead.
Alright, so yesterday we kind of gave you guys a little preview of arithmetic sequences versus geometric. Try and look back through your notes. What is the key piece of evidence that tells us it's an arithmetic sequence? Cheyenne?
Arithmetic is like addition and subtraction.
Yes. Well, remember that later when we get to geometric. Okay, so with arithmetic, it's a repeated addition or subtraction. Okay. And that amount by which we're adding or subtracting is called the common difference. And we represent that with the letter D. Okay, so the common difference. And the thing about common is what everybody has is the same. So if you're repeatedly adding or subtracting the same amount, it's common to all terms. So it's the common difference. So again, for arithmetic sequences, it's when the terms are repeating the same amount by which you're adding or subtracting. So, 3579. Christina, is that arithmetic or no? Okay, why? Yeah, we're adding 2 every time, so that's going to be arithmetic. Now, Christina.
Christina.
No, not Christina. Christina.
I don't get the difference. Oh, I thought it was that one. Oh my gosh.
There's no T in Christina.
I thought it was the other Christina.
2, 4, 8, 16. Is that arithmetic?
No.
Okay, why not?
Because you just add 2 or something. I don't know.
Okay, so let's go back to the definition. Alright, so in order to be arithmetic, it needs to be adding and subtracting the same amount every single time. Okay?
Yeah.
So again, if we're looking at this, we're adding by 2. Next one we're adding 4, and then we're adding 8. So are we adding by the same amount every time?
No.
No, so that's definitely not arithmetic. Oh, too far. Where are we going today? Here we go. All right, now yesterday we talked about recursive formulas and we talked about explosive formulas. So Thomas, what is a recursive formula? What does it do? All right, so in order to find the next term, I have to know what? Yeah, I have to know what the previous term was before that. Okay, that's a recursive formula. So again, notice we said that yesterday we said every single recursive formula is always going to have the same thing. It's always going to start with a sub n equals a sub n minus 1. Guys, what does a sub n minus 1 represent? We called that yesterday. Previous term, yeah? Okay. So that's recursive formula. All right, Kayla, what's a great advantage over using an explosive formula? What does the explosive formula allow us to do?
It allows you to jump to different terms.
Perfect, thank you. Allows us to jump to any term, so I don't have to know the term before it. All you have to know with the arithmetic sequence, these are unique formulas. with the arithmetic sequence. So I want you guys to make sure you make a note of these two formulas. Okay, so when we look at arithmetic, we have the recursive form of that, and then we also have the explicit form of arithmetic. So let's try and write a formula for each one. So we look at the first one, 2, 4, 6, 8, and 10. First thing that you want to do is ask yourself, is this arithmetic? 2, 4, 6, 8, and 10.
Yes.
Okay, definitely you say yes. Why? Adding what? 2 every time. Right? So that tells us it's arithmetic. So therefore, Tristan, what is my D? What is my common difference? Mm-hmm. Adding 2, right? So therefore my D, let's identify that very quickly. So that's always something that's kind of useful. You might want to identify the D as being positive 2. What if I was subtracting 2? What would be my D? Negative 2. So since I'm adding 2, my D is positive 2. So now for my recursive, I'm just going to represent that with the letter R. For my recursive, you just use this template right here. A sub n equals n minus 1, so a sub n minus 1. What's our common difference?
2.
Plus 2. And then you're going to say with a sub 1 equals, so you have to give it a starting point. So what is my first term?
2.
2. And that's done. That's your recursive formula. Not so bad, is it?
How would you use that?
I'm going to be very honest, the recursive formula is not really useful when we're talking about for arithmetic. It's other than trying to find the 7th term, you just have to keep listing that out over and over and over again. It looks more complex than what it actually is. Alright, if I wanted to find the term that comes after 10, all I would do is take 10 and plug it in here. 10 plus 2 is 12, and I get my next term.
Wait, you plug it into A?
A sub n minus 1 is my previous term, so my 10 goes in for that completely. Alright, Cheyenne?
Oh, that's mine.
Okay. Alright, so let's take a look at the next one over here. Again, we'll do a recursive first. What is my common difference on my next sequence? Cordell? Minus 5. Alright, so we set it up exactly the same way. A sub n equals a sub n minus 1. And then we got the plus d, and minus 5 with a sub 1 equal to 9. Right, that's your starting point. So it's your recursive formula. Okay, now let's do the explicit. For an explicit formula, we're going to use this. Again, it's just a template. So a sub n equals, what's my first term? 2 plus n minus 1. Now what's your common difference?
2.
2. And notice that the common difference is in the back here. Normally we would put out here in the front just like a coefficient or distributed problem. And there you go. And then you're done. So explicit is kind of nice. Again, it allows me to jump to any term. So if I want to know the 50th term of that sequence, I can put 50 in for n and I'm done. But if I want to use the recursive, I can't figure out the 50th term until I figured out the 49th term. Okay, Cheyenne?
So if you want to find the 50th term, you just put it in For n and then you just solve it? And
Yeah. So if I want to find a sub 50, which means the 50th term, that's 2 plus 2 times the 50 minus 1. So 2 plus 2 times 49. 2 plus 98 is 100. Alright, so I need you guys to help me out here on the second example. So we got a sub n equal. Okay, so now use our template. Using the template. Okay, so actually, what's my a sub 1? 9, so that's 9. And I'm not going to go immediately for the plus, because if we remember right, Mason, what is my d for our second example? 5? -5. All right, so guys, here's something that's really important. I think sometimes for students who aren't real strong in math, they keep forgetting this really important detail. Negative and minus are the same thing. They really are. A negative and a minus are the same thing. So if I say that my common difference is -5, it's really saying -5 times. All right, and then I'm going to have n minus 1. There we go. And that's your explicit form again. All right, do we have questions on that? Any questions over arithmetic or formulas, cursive or explicit?